Hello, my name is April C. I'm from Aerospace and Mechanical Engineering Department of California Baptist University. My background is from environmental engineering, chemical engineering, and aerospace engineering. My research is from heat transfer, material science, thermofluid science, and engineering education. But recently, I have changed my interest to respiratory aerosol science research, mainly because COVID-19. COVID-19 is one type of virus which is float in air. People try to get protection by wearing different face covering, but people have no idea what type of face covering is effective. In order to give people effective advice, what type of face covering they're supposed to wear, and various circumstances. I have been studying different face covering during the last 3 years. So in this conference, I'm going to present 2 projects of mine. So let's look at the first one. The first one is to use Schlieren and laser flow visualization to verify the efficiency and leakage of different face masks. The main idea of face mask is to block the airborne drops through inhalation. Masks, people know masks is through the filtration efficiency labeled on the box, but people has no direct idea how effective it really is. And mask protective efficiency depends not only on filtration, it also on the leakage fraction. To figure out the effectiveness of different face masks in preventing the transmission of COVID-19, Schlieren optical imaging and laser sheet system will be used to visualize the airflow during respiration. The main objective of this research is to develop an optimal Schlieren system to visualize face mask flows, to study the exhale flows from the face mask and wearing activities, to develop a laser system and visualize the face mask flows, and to use vapor to simulate aerosol transmission between 2 persons. Now let's look at the methodology. First is using Schlieren optical imaging. There's 2 examples with Schlieren optical imaging. The first one, the flow without mask and the flow with mask. We can clearly see the difference and 2 situations. Use laser optimal to visualize the flow through the mask and the leakage. And use vapor gel system to figure out where is the concentration area of the virus or bacteria. Another one, we also use the thermal camera to see how much heat accumulation inside the mask, which can identify the one with best filtration and the least leakage. Now let's look at the result. The first set of results is the Schlieren optical imaging of face masks and wearing situations. Surgical mask, K95, and neck gaiter, 3 different type of face covering was studied, and normal breathing with bracket, coughing, soft speaking, normal speaking, and loud speaking. Let's look at the surgical mask. It's clearly can see with normal breathing, because the flow is slow, it's well spread around the mask with a little bit leakage. And coughing, because the flow is very fast, it's jet flow. So there's not enough time to leak, rather directly go through the face mask. And soft speaking, well spread because slow speed. Normal speaking, still majority spread. And loud speaking, still spread pretty well around the mask, but with leakage. Very interesting for breathing with bracket. The purpose of the bracket is to reduce leakage. We can tell it does reduce leakage, but the disadvantage is it reduces the size of the mask and reduce the flow area. It means it increases the flow speed, and the flow is forced to go through the mask. It means go through the filtration, but the disadvantage is it's getting fast. The filtration efficiency will be lower. Compare with KN95. KN95 and normal breathing, coughing, soft speaking, normal speaking, and loud speaking. Very little leakage and well spread. So the filtration system is efficient. And with breathing with bracket, still faster speed and flow like jet flow. And neck gaiter, not surprising to see a lot of leakage and not filter the flow well. Now let's look at the laser optical imaging. Without mask, the flow speed is slow. With KN95, there is a good leakage on the top of the mask, which is not surprising because one size never fits for all. Surgical, spread well. Surgical with bracket, surprisingly to see there is leakage, and usually with fast flow, you can tell. Slow, very slow flow, laser cannot see it well. So close with HEPA and well spread, but neck gaiter jet flow. Now let's look at, we use gel and vapor to see where is the concentrated area with a lot of bacteria or filtration. So with mask, we still can see on the top of the head, beside the face and the neck, there's spread of bacteria or virus. But behind the mask, the concentrated area is around the nose and mouth, which is not surprising because the inhalation. So people better not touch this area because this is a high concentrated area of virus and bacteria. So through the measurement of flow speed around the face mask and through the face mask and without face mask, we can tell the leakage of the different type of face coverings. Our conclusion is surgical mask and KN95 reduce exhale flow velocity from 2 to 4 meters per second to around 0.1 meter per second. These decrease the transmission of virus-laden respiratory virus, obviously. However, they have flow resistance. The second one is bandana or neck gaiter has low filtration efficiency and high leakage fractions, thus provides very low protection efficiency. 3, respiratory droplets mainly deposit around nose and mouth. Frequent touching those areas will increase transmission. And even K95 and surgical mask can have 50% leakage from the gaps and the nose, around the nose. So it means to increase the protection efficiency is to reduce leakage. If you have any questions, feel free to contact me through my email. Thank you.